Question number 4.2. A buffer solution is made by adding 6.00 times 10 to the minus 2 moles of sodium hydroxide to a solution containing 1 times 10 to the 1 moles of ethane dioic acid. And it's giving you the equation here. So 1 mole of ethane dioic acid reacts with 1 mole of sodium hydroxide. They're the hydroxide ions produced by the sodium hydroxide. Okay, and it makes 1 mole of this ion and 1 mole of water. Okay. Always the first step in this reaction is to work out the number of moles of sodium hydroxide and the number of moles of ethane dioic acid and subtract the two. Then if one reacts with 1 mole reacts with 1 mole, you can subtract the two to find out which one is in excess. Now first of all, you've been given the number of moles of each, so you've not been given a concentration or volume and have to work out moles, you've just been given them. And since 1 mole of this reacts with 1 mole of this, we can do a straight subtraction. So moles of ethane dioic acid and sodium hydroxide have been calculated for you, so that's fine. Which is in excess and by how much? Moles of sodium hydroxide is 0.06, 6 times 10 to the minus 2. Moles of ethane dioic acid is 0.1. 1 mole of that reacts with 1 mole of that. So we can just subtract the two and we can work out the ethane dioic acid is in excess by, because that's a larger amount, 0.1 is larger than 0.06. There's 0.04 moles of ethane dioic acid in excess. That will get you a mark for a start. Okay. The next part is to write an equilibrium constant. An expression for the equilibrium constant or the dissociation constant, same thing. The equilibrium constant for the acid or the dissociation constant for the acid. Okay. So this is the acid, ethane dioic acid, H2C2O4, and we know all acids make H pluses. Now, I could work out what was left, but I'm just going to call it X minus, that's fine. So I've got something else made, H plus and X minus. I could probably work out that it's HC2O4 minus by subtraction and working out what's left over. But I'm just going to call it X minus for simplicity. So, equilibrium constant equals the concentration of H plus multiplied by the concentration of X minus divided by the concentration of the ethane dioic acid. Remember at this point for a buffer you can't simplify, you can't say the concentration of H plus and X minus are the same, so you can't you can't simplify to H plus, you can't do that for a buffer because you've sort of messed around with the amounts of these chemicals by adding some sodium hydroxide. So you can't do that. So we need to do something else. The next step then is to cancel a square bracket top and bottom. So you can cancel the square brackets around the X minus and cancel the square brackets on the bottom around the ethane dioic acid. Just leave H plus with the square brackets. You can do that incidentally because to turn concentration into moles you'd have to divide by the volume, and you'd be dividing by the volume in both cases. So you can cancel both of those square brackets on top and bottom. So now your dissociation constant, the ethane dioic acid, equals the concentration of H plus that's been left alone multiplied by not the concentration now but the moles of X minus divided by the moles of ethane dioic acid. Now what do I know? Well, I know the Ka. I've been given it 5.89 times 10 to the minus 2 or 0.0589 equals H plus concentration. I don't know that, and I know I'm going to have to work that out. If I can work that out, I can work out the pH quite easily. So I've got to find that. I don't know what moles of X is. We'll have to think about that in a minute. What's the number of moles of ethane dioic acid that I've got left over? Well, I'll work that out in the previous part of my question, 0.04. So I've got 0.04. The only thing that's stopping me now from getting the concentration of H plus is the moles of X minus. And here's the trick. The moles of X minus equals the moles of sodium hydroxide in the initial part. You don't really need to know why. If you really wanted to know why, then X minus is made. It's this ion here, H2CO4 minus. That's the X minus. It's made when the sodium hydroxide and the ethane dioic acid react. So the number of moles of sodium hydroxide used equal the moles of X minus. But you don't need to know that. All you need to know is that you need to find this, and you look back and you find that's the number of moles of base or the number of moles of hydroxide in your original question. Now you've got that, 0.0589 equals H plus multiplied by 0.06 divided by 0.04. I would do that a little bit first, work out that it equals 1.5 and multiply 0.0589 by 1.5. and you get the concentration of H plus equals 0.039. The last part of this section is that pH equals minus log to base 10 of the hydrogen ion concentration, so it equals minus log to base 10 of 0.039, 1.41, which seems like a reasonable pH for an acid.